This is the 2016 Impacts and Collision question 5b. We're told the velocity of P after impact and the velocity of Q after impact, and we have them where J is along the line of centers in this question, so no change in the I. So let's set up. We have two identical smooth spheres, P and Q. Q is on top this time, P is on the bottom. P is coming in along this direction. We give it an x-axis, it's going along that direction, and then it's coming back out in this direction. And part 2 of the question is the angle through which the direction of motion is deflected for P. So we look for these two angles here. So let's set up our equations. They're identical, so we'll call their masses m, and we're told the velocity of P after impact is 3I minus J. This is P, this is Q, and the velocity of Q after impact is 2I plus J. So in this case there's not going to be any change in the I, so we're going to have 3I plus P in the J direction and 2I plus Q in the J direction. We're given the coefficient of restitution to be a half. E is equal to a half. So setting up our equations now, we're using the J velocities, so it might be handy to put ones in here. So we're going to have minus 1 over P minus Q in the opposite direction to the way it is normally. That's equal to minus E minus 1 over 2. So minus 2 by 2 is equal to P minus P plus Q equals minus 2 by 2 minus 4. And then for my principle of conservation of momentum, we're going to have m by P plus m by Q equals m by minus 1 plus m by plus 1. So you can see here we're going to get P plus Q is equal to 0. So that should help us solve it pretty quickly then. If P plus Q is equal to 0, we're going to get 2Q equals minus 4. So Q equals minus 2. And if Q is equal to minus 2, P must be equal to plus 2. 2 minus 2 is equal to 0. So now we have the velocities before. We have for P 3I plus P times J, so that's plus 2J. And for Q we have 2I minus 2J. That's what we're asked for in part 1. In part 2, the nearest degree, the angle through which the motion of P is deflected by the collision. So we have our diagram. Afterwards we got 3I plus 2J. So we have a 3 and a 2. And that was before. Afterwards was 3I minus J. So we have a 3 and a 1. I know it's not an isosceles, but let's just do it for the sake of argument. So this angle here, the inverse tan of 1 over 3, and we'll have to add the inverse tan of opposite 2 over 3, and the inverse tan of 1 over 3 gives 18.4 degrees, 43, and the inverse tan of 2 over 3 gives 33.69 or 33.7. So adding these two together we get 51 and 1.1, 52.1 degrees is the angle of deflection.